So yeah, we can do that, and then we got the LEDs. So I think if we can just make the LEDs change color according to what the temperature is, then that'll be a good start.
Yes.
So you have Arduino installed. Or,
Yes, I do have it installed.
so what's your setup now? Do you have the ESP out? Yeah, it's a bit difficult now not seeing exactly your setup, but you can share your screen, right? So if you code, then I can see.
Yes.
Great. Okay, so you have the ESP there? Is your USB connected to it? Let's just try a program to it. So have you done the tools board setup yet or not?
I haven't done anything at the
That's fine.
moment.
So if you go open Kerry's tutorial on YouTube, I think, because you have to set it up. So what you have to do is now the Arduino IDE can use multiple different boards. So it's actually made for the Arduino, but the ESP has the Arduino. They call it a bootloader. So it has the Arduino bootloader on it, so you can use the Arduino to program the ESP, but you have to tell this program that you want to talk to that board. So we have to set that up.
Okay. I presume this is the Plump Up YouTube one.
Yes, but I'm not seeing it. Yeah, it doesn't matter, man. But you don't have to worry too much. Just go to just the videos, and then just go to where she says installing Arduino for ESP. That second one on the right, second row. That one, yeah. It says ESP32 orange.
Yeah. Oh.
Yeah, there we go. And just say show more. So you don't have to watch everything because I'm here. So if you just go there, so you've installed the IDE. No, you've done that. You've done that already. Yeah.
Yeah, I've done that one.
So now, you can actually just go to the website. Click on that Plumpot. I actually wrote a post about it. Yeah, that one. Cool. So you've done that. Go down. You didn't have to contribute. Down. Okay, there we go. So that's what we have to do now. So we have to go preferences.
I'm just going to put it on the second
No, of course, man, I understand.
File. Preferences.
Yeah, then additional board manager, you're going to have to copy a URL there. There at the bottom. Somewhere there should be like...
additional.
Yeah, so there you have to...
Oh, there it is.
Yeah.
Copies.
There we go. And then, yeah, you can just follow the instructions of it.
Press OK after this then.
Yes. Just follow those instructions. It should be fine.
So I haven't got the fastest internet in the world.
No, that's South African problems. I understand.
Yes.
Yeah, I'm trying to help that.
Well, I just go back to tools board.
ESP32 at the bottom, dev module. There we go.
Cool. I think that's right.
Yes. So if you go, is your ESP plugged in?
No.
Okay, so put the USB plug it in, and you should be able to. They might be installing the drivers first. There should be lights coming up and etc.
Can I leave it connected into the phone, or should I rather take it out?
To the phone.
Yeah, just it had a polystyrene foam attached to the bottom.
Oh, foam! I thought you were trying to power your phone. Take it out. Foam is not conductive, so it should not be an issue. It's just for packaging, but take it out because you're going to have to use those pins to read the values of your sensors. If you go to tools, you'll see serial port or something. Yeah, serial port at the bottom, fourth from below, it says port. If you unplug it, does one of them go away? Yeah, you're going to have to just go out that window and back in. Yes,
Yeah.
so if you plug it back in, then you click on that COM port.
The COM port 6.
The ESP that I got you, is it with a battery, or is there two buttons, a EN button and a boot button?
Yes.
Okay, cool. So what you're going to have to do is, when you push the upload button on the second one on the left, on top left, there's a tick mark and then like a load button on this page. If you go underneath file and edit, yeah, that one's upload. So it's going to upload the sketch to, if you click that, yeah, you press it, but then you also have to push the enable button and then the boot button, I think, before it can upload. So
Both of them
you got to hold both the boot and enabled in, then release enable and wait for the dots and dashes to change to downloading message, then let up the boot.
Okay, so hold both, then let enable first, then hold boot last.
Yes, but only once it starts uploading, I think. So hold both boot and enable, then release enable. You can release now. There we go. So now it's writing. So now it's writing your program there. Hard reset.
Okay.
So now this program's on your ESP, but this program's nothing. So now we can start. So you have, where is your waterproof temperature?
Got it in front of me.
Okay, so there's 3 wires, red, black, and a middle one.
And a yellow one. Yes.
Yellow one. Okay, so the red is always voltage, black is always ground, and the middle one is the signal that you're going to put towards the ESP. Can you open that website that I sent to you, please? Yes, so okay, cool. So it's actually that IC that you see on the right hand side there, that's inside there. So it's just metal casing to conduct the heat. So yeah, so it's a side. So if you go down. Okay.
So that is installed in the board itself.
In that top edge, yes. Go down. So that I have to connect it. I don't think you need a. So normally what happens is if you've got a signal that goes to a pin of a microcontroller, the signal, like it goes high, low. But if it's just floating, you might get a lot of noise. So they pull it down with the resistor to make it 0, to make it ground. So when no signal's on it, it will always be 0. If you don't do that, then it will get like 0, 1, 0. It will just a lot of noise.
Okay.
But I think in the inside of that whole setup that we got, they do this inside. Well, I hope so. I think so. So that's how we can connect it. So we are going to take the red one. Do you have a breadboard with you?
I do, yes.
Does the wires go into the breadboard? I didn't actually look at this.
What do you mean there's some wiring?
If you take a wire, you can push. Do you know how a breadboard works? Or not at all?
No.
Okay, cool.
Not at all.
So, no, it's fine, man. So a breadboard, if you look at the picture in front of you, the bottom 2 rows, they go left to right. So the top one will be ground. You see where the black wire is in? At the bottom?
Yes.
So there's
I can. So that one there.
Yeah, so that one's in there. And then that whole row from left to right is connected.
That's one.
The whole row. So if you go from the left to the right, that whole row is connected.
And as in these ones, yeah.
Yeah, the top one. No, yeah, so but the row. No, is that where you are, the black one? So the whole row there is connected. And then the bottom one where the red one is, that whole row is connected. So that so it's just to get the power over. But then the other side where you see the component connected, then it's connected from bottom to top. So so you're actually putting power to the right pin. You're getting the signal from the middle pin, and then you giving ground on the left pin. So that's how our breadboard works.
Okay.
Easy.
So ground is top and power would be bottom.
Yeah, you can see on most breadboards they'll have like a red line and a blue line. That's to indicate the convention, but it's just connectivity, so you can connect it whichever way you want to. It's not like it will still work if you put the red one on top and black one on the bottom.
Okay.
It's just convention that they show red. So if you get back in 5 years and you look at it, you're like, okay, I use this for my power. It's just, it's convention.
Yeah.
But it's not a smart breadboard. The breadboard doesn't care what you put in.
Okay. As long as you put them in the right place.
Yeah, just don't mix up. Don't let black and red touch ever. So if you take that DS water temperature sensor thing, the ends of it where it's stripped, the red, black, and yellow, can you push it into a breadboard?
Okay, they're not stripped properly, but
Does it fit in a breadboard?
No, does not.
The headers that we got. So I think I got male, female, female, or what?
Yes.
The cables. So does the female get? Can you put the female in? Can you put the sensor into the female? Sounds weird. How does this look?
Which one's? Oh, wait, no. Yeah, okay.
See, it's not. It's not stripped. Can you strip it? It's not stripped,
I don't have it. No, it's not stripped.
Okay, you're gonna have to strip it.
Let me see if my friend's got a stripping cable.
Ask him. What I do, what I don't think people should do, is I use my teeth.
Yeah, I can't do that with my teeth.
Okay.
Let me just go see if he's got it, and I'll be right back.
Yeah, cool, man.
Yeah, I managed to strip them.
Oh, did you? Sweet.
Yeah.
Does it fit in the breadboard?
And going to now check. Seems to.
Nice.
I don't know if it's contacting or not.
No, if it's in, it'll make contact. So put the wires like you said in the picture now with that component. So put a red one in one side, the yellow one in the middle one, and the black one on the left hand side.
Okay. So with these ones here.
No, on top.
No,
on top. So simulate that, because that is the component you actually have in your hand right now.
Okay, so this would be black.
Red.
So black. So red, yellow, and black.
Yes.
Okay. Does it matter what number it is?
What do you mean number? In the breadboard.
So like there's A, B, C, and 5, 10, and all those.
So no, because it's all connected to one another.
Okay.
So A, B, C, D, E will be all connected in a single column. Just give me 5 minutes, I'll be back now. Or 2 minutes, or less than a minute. I'm back.
This is more challenging than I expected.
To get it in?
Yeah.
Maybe try the jumper wires. So we've got jumper wires there that's got a female side. It might be easier to get it in there.
Yeah. Entire rainbow. Can you strip these individually off?
What do you mean individually?
Like the jumper wires are all stuck together.
No, yeah, you can break them apart. That's not an issue. They're supposed to. It's just easier for packaging for them, I think. What do you have? Female to female, female to male?
I've got both male to male and a female to male.
Okay, great. What else? Does it fit in that?
Yeah, it does.
I
dropped it.
Everything's still fine?
Yeah. When you put them into the female part, they start to fray a little bit, the wires.
Yeah, what I normally do is
They don't stick.
I normally roll them in my finger to make them a bit like into.
I'll try and cool. I think I've got it.
Cool. So then you can take the male side and then
Shove them into the PC.
Yes. So you got female to male and then male to male. Okay. Yeah. Put them in the breadboard.
Yeah, I've got that. So I've got them plugged into the breadboard and onto.
Then you're going to take a middle. So then you got to give it power, right? So let me think what the best way is. Can you look at my screen?
Yes.
Okay, cool.
Just
So
a screen?
breadboard's got 2 rows at the bottom here.
Yeah.
So that's our power. So let's say the top one is plus. So take a male to female and then put the male in here. And then on the ESP32, there should be a pin that says VN.
VN, yeah.
Yeah, so then you can take the female part, just unplug your ESP for now. So don't give power to the ESP yet. Let's just see let's first connect everything and we plug the power into the ESP.
IN.
So you took a cable. It's always nice to have the color. So if you have a jumper that's red, I would use
Yeah.
a red one. Okay. So you took it from a line here. You're still looking at the screen, right?
Yep.
So you still took it from here, and then you took it there to the ESP to let's say VN. And then you're going to take the bottom one, and then take it also male to female, and plug it into the ESP, just ground, wherever you find a pin called ground. You can see on the pins there's names.
Should I choose the one on the same top row?
It doesn't
So
matter.
I've got 2 grounds.
Yeah, it doesn't matter. The grounds are all connected to one another on the board. So it doesn't matter which ground you use. There's hardly ever separate grounds on electronics. So on the voltage side, on the pins, I think there's 3.3 volts, and then there's VN, if I'm correct.
3V3.
Yes.
Yeah.
Use. Okay, I'm gonna.
So I've got a,
Yeah. So take the red one, and
yeah.
let's rather take it to 3V3. So don't do VN, do 3V3. So 3V3 is yeah, it's the voltage, but the USB you plug in is actually 5 volts, and then it steps it down to 3.3 volts.
Okay.
But I just want to check what this can handle. Are you looking at my screen?
Yes.
So see, so it's 3 to 5.5 volts. Yes. So it can handle 3 to 5.5 volts.
Okay.
But the problem is when you have a data line like this output, I don't actually know, is it digital or analog? I think it's digital. Yeah, it's 9 to 12 bits. You see there? Anyway.
90. So what's the digital analog? Is that the sensor reading it?
Yeah, so you get 2 different sensors. So the sensor can either be analog, so it's like a sine wave, so if it goes high it will go like this, or it's digital where it's just ones and zeros, that's all it is.
Okay.
Then the ESP will take this depending how fast it goes or how long it goes, and will turn it into information. But the problem is these on the ESP, this level here is 3 volts, 3V3. So
Okay.
when you have a system that you have to give power to, you want the supply to be as close as possible to what the digital signal supply is. So if we give this 5 volts, but it outputs 3.3, this difference is not good. So you want to be as close as possible to
Do what it needs. Okay.
yes. So that's why we make it 3.3. So analog is just, it's a value from, let's say, 0 to 5 volts, where digital is 0, can also be 0 to 5 or 0 to 3.3, but it's either off or on. It's like a switch. And
Yeah,
depending how
okay.
fast you put on the switch or how long you keep on the switch will determine the information. But you don't have to worry about it. There's people who write code, and you're just going to take that and use it. But it's just the background of it.
I sent a picture of what I've connected.
Okay,
Just
let's
wanna
see.
make sure that is.
Nice. Looks good. That looks good, man. That's neat. So, okay, now we're going to take a part here. So we're going to take the 3v3, take a male-to-male connector, and plug it at the bottom of that pin. And then you're going to take a male-to-male connector, a male-to-female connector, sorry, and then take it from here in the middle to the this will go to the ESP. I'm going to check now which pin we can use.
So I need a power one for the where you've connected the 3v3 to the actual temperature probe. That little red line.
Yes.
Is that just the one below it?
Yeah. So it's going. Yeah. So just
Okay.
one. It's going to be one
'cause it goes
below.
down.
Yeah. One below, two below. Doesn't really matter.
Yes.
But let's find. What does that website say that we shared? That's on Discord, right?
Yes.
It's a nice photo. Discord's not bad. So did you take a photo on your phone and then send it to your email or to your computer and then did it? Or
I took a picture on my phone. I've got Discord on my phone as well. So
oh, nice.
So I can use my phone for videos and that if you need to see what I'm doing. You just have to deal with the cell phone quality audio on it.
Cool. I just want to see what pin they use. They use a pin 4. Pin 4. What is pin 4? Around sensor drives a power dot line in case this schematic. We don't need weather. You can read the temperature of more ones at the same time using just one Arduino. Cool. So we can use any digital pin. That's fine. So, what pin are we going to use? USB 32.
Are these the D2 to 15 or 25?
What do you mean?
On the board it says D13, D12.
Yes. So if you look at, what's going on here, man? Can you see the screen? Yeah.
Yep.
So I think this is kind of what you have. Might be a bit different. Well, I don't know if it's exactly the same. Do you have a ground V in at the bottom here?
So I've got my top 2 pins or by the power source. I see, right? Yeah, V and ground. Yeah.
Okay, cool.
That is it.
Okay, nice. So yeah, so these are the pins, the GPO. So these are what you're going to use in the code, but we'll get there later. So you're going to say,
Okay.
I want to read something from 25, it will be this pin. So we can actually use any, and then you can see some of them are analogs. So analog channel 1, analog channel 3. So ADC is all analogs. We don't need analog for this. So let's use dash.
Which ones are the digital ones?
All of them can be digital.
Oh, okay.
But I don't want to use the analog because you might use it later in life. What's your favorite number?
13 generally.
13.
Yeah.
Let's use 13 then. On your board, does it say?
Yeah.
Does it say GPIO 13 or does it have pins and a number or just GPIO?
So it just says D Delta 13.
Okay, use
That's
it.
next to the green, the ground.
Next to the ground.
Yellow.
So it's this. But you have 2 grounds on the board, right?
Yeah, so it's ground next to the VIN bin one.
Oh,
Yeah, that one.
so that one.
Yeah.
So that says 11, yeah, but it might be different. So yours says 13 there.
Yeah, mine says 13 on that one.
Just want to check something because sometimes confusing that they sometimes. So the most controllers either they've got the physical pin number, so 1, 2, 3, 4, and then they've got the software number what you're going to call. If you know what I'm trying to say. So you're going to use
Yeah.
show you. D13. 12. VPP. Okay, no, do it. Put it in 13. Don't put. I need to get the one that we're using because everyone is different manufacturing. Don't they have a data sheet? Damn it. DevKit C. Normally when you buy it, they've got a data sheet. Just want to make sure. Yes, so this one you have. Yeah, so D13, so that's perfect. So you can see it's been, yeah, actually, D13, go for it. So you're going to take the middle one, this one, and connect it to your 13, D13. Happy?
Yep.
And then you're going to take your ground, so you're going to take ground from here, somewhere, yeah, it doesn't matter, at the bottom, and take male to male, and then connect it to the bottom of the black one.
Cables everywhere. My friend did warn me this is not going to look pretty, so don't get us.
No, but that's exactly what we're going to do. So we first see that, okay, cool, we got something working, and then we can make a PCB, because it's much easier to troubleshoot like this than make a PCB and, oh shit, something's wrong, and then it just chaos. So rather do it like this. It looks ugly, it does, but it's just the concept.
Yeah, and you can reprint it. Otherwise, you have to reprint it every time.
Yes, exactly. So
wait for time
most people will take off the shelf components, build it, get the proof of concept working, and then you can go from there. And then we can make it pretty and all that stuff. Cool. So once we connect it like this, we should be able to get started.
Did I download these ones then as well?
Let me just look at your screen. Oh, have you plugged it in already?
No, I haven't.
No, I mean the wires are all connected.
Yes.
Oh, yeah. Now we can get to it. So I'll just make double sure that. So we got red in a line. Can you just take me a photo of how you connected it? Because I don't want to plug it in and ground is shorted to something, and then we're gonna have trouble. Oh, you already took photos. That's nice.
It's just of the actual board,
Yeah,
so
yeah.
you know which one it is. So if you're going to be able to see this, might need to connect it a bit more. Yeah. Connect it a bit more simple or exaggerated.
Yeah, I just want to make sure because if they normally have protection, short circuit protection. So short circuit is just when ground and supply touch each other and bam, magic happens.
No, no, photo up. There we go.
Oh, nice photo. So we got red. Okay, um, so sometimes what happens is you see the bottom. It's got like rows, 2 rows, a gap, and then and then another rows. So it's like five columns in each row.
Yes.
So sometimes they don't make it go all the way through. They do some breadboards do, some breadboards don't. So sometimes they um, break it into parts. So the first 5 will be by itself, second 5, third 5. You know what I'm trying to say?
Yes, yes.
So maybe just move your other 2 on the right, just in the same 5. Then we know they're definitely connected.
Okay.
But I think it should be fine. But I don't know. With every breadboard's a bit different when it comes to that. But then you got red to that red. Yeah, looks good.
Put
Looks
them
very.
right next to each other, so there's no doubts.
Yeah. But red on top. Oh, that's nice. That's nice. So we then have a winner. There. So is your ESP plugged into your laptop?
The cable is just, it's easier to unplug the USB port rather than
Yeah.
on the board.
Okay, great. So now we can carry on with it. So plug it in and let's see what happens. If you don't see smoke, it's a win.
Let's get my fire extinguishers handy. Okay, we've still got a red light.
Okay, the LED light's still on, right?
Yeah, red
Great.
light's on.
So now let's carry on with that tutorial. Let me just look at your screen. Okay, there we go. So we're going to do that. So like I mentioned earlier, someone already wrote the code for us. So
Okay.
let's do this. So let's install OneWire. So
Library.
yeah, manage libraries on top.
Noted.
Not maybe it just looks a bit different.
It says it should be by Paul somebody.
It doesn't. It depends how old this is. Make it small letters. See what happens.
Guys, just copy pasted exactly what it said.
Oh, but in the picture it's different. Wait, anyway.
By Paul Stroff. Okay, yes. There we go.
Yes.
Scott Roberts.
Install. Nice. Now Paul saved us, and because so we don't have to do any work. Dallas. Just have a look at the picture. Is it the same? Yeah. Mark Burton or someone. Install.
So,
I think we can start programming now. So if you go close that, and on the left hand side, yeah, you can keep this. You can keep it like this. Maybe just make it a bit bigger. You don't have to make it full screen. So now we're going to have to include that with libraries we just installed. So if you go tools, I think, sketch, sorry man, sketch libraries where you were not, no. Include library, second one from the bottom. And there you should find new ones that you just installed. So look for OneWire. Yes, click on it. Boom, now it's there. So now you can use all the code that Robert whoever wrote. You can use it here and make life easier for yourself. Now look for Dallas. Down top, the fourth one on top. There we go. There we go. Now we can, so now we define one wire bus. So if you see that hash define one wire bus 4 on the right hand side.
So this one.
Yeah.
Define bus 4, yes.
Yeah. So take that code. So what that does is actually yeah. So if you want to comment in, yeah, just copy the whole thing. Doesn't matter. So if you want to comment something, because every time you write something coding, the computer will think, okay, I need to do something. But if you just want to write normal text, you just use 2 forward slashes.
Okay.
So now they're saying, okay, this is for this. But now, so what they're doing now is they're defining pin 4, in your case, pin 13, so change the 4 to 13.
Okay.
So they say, okay, when you read this code, you don't want to see 13 the whole time. You want to have a name for it. So they say, okay, I define this name, the one wire bus, it's equal to 13. So whenever I use one wire bus, it is linked to pin 13.
Okay.
You understand?
Yes.
Okay, cool.
So
Yes.
name.
Yeah, so you're giving it a name, so it's easier to understand as a human being. Okay, then at the bottom there you can see set up one wire instance.
Yep.
So take that code as well. So you can see that one wire is like orange. That is just now, if you go into, yeah, so if you go into that one wire H, don't go in there, you'll see there's a lot of, it's called functions and methods. So someone wrote a lot of code that you could put something in and something will come out. So you are taking a piece of their code called one wire, their function, and you just say, okay, pin 13, you're going to read this information. I don't care what you're doing in the background, but you're going to give me something out.
Yeah.
So yeah, it's a bit cheating, but someone did a lot of work for us, and we're very happy, and now we're going to use it. Now we do the same with the Dallas temperature. So that one wire is actually just a protocol, so of taking information, that digital that we spoke about, going 0, 1, 0, 1, 1, 1, and making it into something that we can understand.
Okay. And they gone into that's got the program says this 1 means this 0 means this. This is how often you have to switch it on and off. And this
it's amazing actually. Yeah, it's crazy. If you think what's going on in your computer and stuff, and then people are these celebrities that just take photos and become billionaires, and there's people that's making magic we don't even appreciate. Anyway.
Yeah.
Cool, so we've done that. We've got the same name, sensor 1 wire bus. Cool, now we've called the two programs we've got on top. Now we've got to set it up. So the Arduino program always has two ways of doing, or two, you see setup and loop. So setup is just where you're gonna set your whole system up. So where you're just gonna do something once. So the loop will run the whole time once you start the program. So let's copy that. Sorry?
So setup would be what you do when you start it up, and then loop would be constantly monitoring.
Yes, exactly. So you can copy that serial up again and sensor stop again. So that serial.begin 9600. Have you heard about baud rate before?
No, I haven't.
Okay, so when you say tools port and you choose a port, your USB communicates at a certain speed. So it's either 9600, 115, 200. So we are just saying we're going to read the information at that speed. But we'll get there.
Okay.
I'll show you later when we look at the temperatures. And then that sensors.begin is probably just a function in one of the libraries that we have on top, H, that we're going to use now. So now we can go to loops, and now we're going to actually do stuff. Sensors. No, sensors is, if you look at the top, Dallas temperature.
Yeah.
So
sensors
so that's where it comes from. So now you can actually just copy that whole thing at the bottom, the loop. Okay, cool. So what we're going to do now is we activated the sensors in the setup. So now it's sensing. And then we just say we request a temperature. So that request temperature is again code that's written in that H file on top. We don't need to understand it. And then, then serial.print is we are going to print through the USB to a monitor so we can actually see it. That's why the 9600 was so important. So more than one IC on the same bus. Okay. So now they get temperature indexed by index. So it seems that you can have more than one temperature on the same line, which is strange, but it's cool. So we can have more temperature sensors using the one wire, it seems. But then we're just going to choose which one we're going to talk to. So this one's 0. So in programming, you don't count 1, 2, 3, 4, 5, 6. You count 0, 1, 2, 3, 4, 5, 6.
Okay.
So your first one's always 0. Compile it and see what happens. So if you go on top left, the tick, there's a compile. Let's see. Yeah. So this won't upload it. It will just compile to say if it's fine to upload. You must first save your sketch. Always save.
It's an ESP, yeah. Huh?
Yeah.
Not either.
Yeah. Oh, it's done. So that means the program you wrote has no errors. Well done, man.
Thank you guys for writing it for us.
Cool. Now let's try upload it.
Okay.
So you're gonna have to do the same with the buttons, eh?
Oh, fine.
Yeah. Unfortunately, you have to do it every time.
So it was hold them both down.
And then let one go.
And then let Ian go.
Yeah. Let's see what happens. But it's only when, yeah, so only when it comes, so it takes a while now. When you see connecting, you can do it. Yeah, try now.
Putting,
Nice.
and then let that one go.
Boom, it's programmed. So how do you know if it works?
No idea.
On the top right, you can see vergrootglas, magnifying glass.
Yep.
Yeah, click on it. So that's your monitor. So that's where you're writing.
Okay.
Is it writing? See, so at the bottom right, you can see 9,600.
Yep.
So that is right. So that's the same as what we said at the beginning. So
Yep.
that's why I say serial.begin 9,600. I am talking at that speed, and you're telling this guy read it at this speed. Push the reset button, the enable button to reset the program, but leave this on.
The EN button.
Yeah, just push it. You'll see the lights flash and it should go in just reset like that. There we go. But that's all wrong. Is it minus 127 in your house?
Okay, maybe I don't have the cables properly connected.
Or 13 might not be 13. But you see now it's pushing out what you wanted.
Probably the lowest it can go, 127.
Yeah. Sometimes what happens, it's not actually 13, so it might be pin 13, but something else. Let's just check.
Because you said there was a program name for it.
Yeah. Try to make it 20.
Let's change it here. So it'll be these two that I need to change.
Yeah, see the top one is just text, so that doesn't matter. That doesn't affect the program. But yeah, that one. Try and make it 20. See and upload and see what happens. But open the port first. You can actually, yeah. Now you can upload. Now you can push the upload button. No, yeah, other one. Yeah.
And do the same process?
Yeah, you have to push those buttons. Still the same. And you plug it into 13 on your board. Maybe you can't use 13. Let's try another one. Let's try... let's try D35. So you're going to have to move it on the ESP.
Can I do it while it's plugged in?
Yeah, it should be fine. You're going to have to reprogram anyway. You moved it on the ESP as well, right?
Yeah.
Cool. Push the enable button. Don't know why it does that.
Yeah.
No, it's still negative, so it's still the same. So it's maxing out. Let's just maybe the tutorial.
I'm just gonna unplug it again.
Yeah.
Let's connect the cables a bit better for the temperature.
I'm sending you new links. Let's use this because this is coming from NetRam's website itself. Are you there?
Yep. Sorry, it's sorting out.
So let's open this new website and rather use that. What time is your competition? 10 minutes.
I need to leave at about 2.
Okay. No, if we can get this working, then you can go prepare yourself and kick ass. But I think it's the code we're using, so maybe we're just not using the right code for the sensor. So yeah, just open the link that I sent in Discord.
Reconnecting the temperature to.
So rule of thumb is use the website that they give you on the place where you buy the component. Don't be a hero. So there you'll see, yeah, go down. We know how to connect it. So there we go. So we need to install that DSH. Yes. So where you install your library, go search for that.
No management over.
That's the one we installed, eh?
Dallas temperature. We didn't install Tim. Yeah.
Yeah, and what's the? It's already installed. What's that one?
This one is a different one.
Yeah, no, I'm just saying one wire. What? What's the name of it? One wire mob.
Hub. Yeah, so it's a different one.
Okay, there you are.
Why is it included twice?
I think it's a mistake.
Doesn't have 1 hour dev.
Okay, no, that's fine. Just go down in this tutorial. There's library. So it seems that it's the same as what we have. So, because you can see that it says DS18B20 class is the parent of one wire thermometer, which we already have. Just include, yeah, let's try this code. No, that's the one you already installed, I think.
Yeah.
Dallas, yeah.
Because that, oh, there's the one.
Yeah, try that. Install it.
Let's see this one. Because yeah, that was the Dallas one.
Yeah.
RT, it's not that one. That's just the events. Why one more have? Okay.
Okay, let's
So
just
which one?
yeah, let's just go to the code. Yeah, you can include it so long.
This is. See this one. This one wire has got a CRC on it. I don't know if it's slightly different.
No, I think it's already all included in one wire. We can go to the code. Yeah, just add it. Now go to the code on the left. Let's just see. So they include it. Yeah, but this is not Arduino code, man. No, man, this is nice. Why would NetRAM give this? Why would they make life difficult? Code the code and the official to make this go. If you go to your Arduino, so if you go File, let's try this File, Examples, and then there's sometimes they give samples with the libraries that you don't. So sensors, we'll go down. Temperature, no. Do you see somewhere that anything to do with the temperature or Dallas temperature at the bottom there? Right at the bottom.
There's just all those ones.
Yeah, so single. Let's just test it. Yeah, what happens if you click that? Shoo. So make that number, change that number. Whatever you plugged in now, 20 I think, or
35?
35. Okay, let's just see what they do. So they make the port, control library demo, locating device, so it tries to find the device. We didn't do that. Device found. If sensor is on, do something. Unable to address device, print address. Upload this and let's see what happens. Because then we can at least see if it's finding the device. Go to the monitor. Take the auto scroll away. On the left bottom, and then go up. Unable to find the address. Press power off. So it cannot find the address for this device. It's interesting. So that's probably has to do with that one wire protocol. Do you see anywhere on that page? Let's see. We'll use just one and go to our support terms.
Oh, sorry, there's a bird trying to get into my room. And a cat sitting on a chair looking very happy.
Crazy. Crazy. Documents. To make the code briefly, load the code. Go to another, yeah, this example code. It's a bit more complicated than I thought. I thought I'll just give you a thing, but there's a lot of ways to do this. Go to the examples again. Let's just have a look. What examples are there?
Examples?
If you go back to file examples.
Oh.
DS, go to DS. What does DS show us? Single. So complicated of us.
There is a D4. Should we just copy paste the original program and see if it works with D4?
Yeah, try that. But it's something, it's not addressing it correctly, which is strange. Let's see what happens. No, it's still minus 27. So it's not seeing it somehow. Go to examples again and go to one wire. So one wire is a type of communication. I've actually never used it before. So we need to first be able to talk to it before we see anything. Right at the bottom, one wire, and then temperature, the first one. Does this more realistic? So that's got pin 10. Upload this, put it, but you're gonna have to change the wire. You're gonna have to change that. The 10.
Change
You're
it
gonna
to
have to
10.
do 4. No, to 4. You're either gonna have to move your wire to 10 or change that to 4. You don't have a.
So
Your roommate doesn't have resistors, though.
I don't think he has resistors.
Okay, damn it, I was hoping. I don't know if they built it in.
Does it change it automatically, or
What?
any reference to DS10? Or change it to DS4?
Yes. But I'm worried that we don't have a 4K resistor. So that might be the reason why it's not working. I was hoping they've got the resistor inside. No, that can't be.
Upload this one then.
That can't be the case. That can't be the case. You can try, but I think we are missing the 4K resistor. Damn it. Yeah, I don't think it's gonna work. No, leave it. It's trying to find something, I think. Yeah.
I can quickly go ask him and see if he has got a resistor.
Just ask, because otherwise I'll try to send you some.
What do you need? A 4?
Anyone between 4K and 10K. If he has resistors, we can make a plan.
Okay, I'll go check quickly.
Thanks, man.
Unfortunately, he's got no electronic
resistors.
components. Yeah, he's got nothing here. It's all that Joburg.
Joburg. Ah, damn it. Cool, then I'll organize that, because I think it's needed. I think it is needed. So what I spoke about earlier is this pulses of digital. So if it's not grounded by that 4K or pulled up, then it might bounce from high to low, and that disrupts the reading of it. But I'll have
And the resistor just makes it digital?
No, the resistor, what resistor does is when it's in a state where no communication is done, it keeps it at a certain level. So when it's not being asked or spoken to, then it will just make it a high the whole time. Otherwise, if you
Okay.
don't have the resistor, it will just float and it will jump high, low, 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 and it just makes interference. But I was hoping maybe somehow they built it in, but that won't be possible because it has to be pulled up. Is nie goed, is nie goed, is nie goed. I'm just thinking what we can try. What pins do we have? I wonder if we can internal pull up. Let's see if we can do that. Let's see if we can do that. That might help, that might help. So sometimes with the microcontrollers, they've got internal pull-ups on the PCB, so we can do that. So I want you to try this. So in the setup, I copied you some code. Just copy that.
Okay. On this one.
Let me just see. Yes, on that one. But now we're going to make it to 17. So you're going to move it to 17. But yeah, in setup, copy that code.
Setup.
Yeah, under setup, yeah. Yes, so we're going to make it internal pull up and then we're going to see what happens. But then one wire bus, make it 17. On top,
One
yeah.
wire bus. And I move it to 17 on the board.
Yeah.
I don't see a 17 though.
Oh shit, really? That plan backfired. Why not? What do you have? What do you have? What do you have? Maybe we can use another one. Yeah, there's probably no 17. No 17. Then these people are lying to me. Why would they lie to me? So there's no 17. There's no 17.
No 17, I couldn't find one.
Is there 27? It's confusing me now. Yeah, I'm looking at your picture now. D27. Do you have a 5? 5, 5, 5, 5, 5?
Yes, I've got a 5.
Use 5. Let's just try to use 5. Where do you see 5?
It's bottom just under the...
Ah, I see it, next to
Gray
18.
block, yeah.
Yeah. Okay, cool. Use 5 and then you're going to use the same code. But now you're just going to say pin 5 input pull up. Yes. Upload, let's see what happens.
That looks better. There you go.
Working.
24 degrees.
Oh, we are geniuses. Now blow on it or something. Put your hands there, do something.
Yeah.
Yes, man.
26.
Yes, man.
Hey, it's all done.
Okay. Okay, so let me just understand. Yes, man. Mooi. Okay, if you look at my screen again, let me just explain what
Yep.
happened. So we got pin 5. So we got our pin 5. So what they wanted us to do was we got our VCC, which is the power of the sensor, and then we got our output, and then we got our ground. So here this goes to pin 5 normally, and now they wanted us to put a resistor here and ground it, or not actually ground it, actually connect this to a voltage 3v3. So this is called a pull-up resistor. So when nothing happens, this value here will always be 3.3 volts. If you understand. So on this output, you'll get this. So you'll get when the temperature gets pushed out. This is what we get. But let's say the temperature is not being pushed out, it will just be straight high the whole time. But now without this resistor, you'll get this funny stuff, just noisy.
Okay.
But now with the now with the ESP, so this is the outside world. Now with the ESP, they made it quite nice that on their PCB, on their PCB inside here, they've got their own pull-up resistors.
Okay. So we just have to find the right one.
So they've got their own pull up or pull down. So you can choose. So what we did now is we said pin 5 internally give us a pull up resistor. So then it says, okay, I'll use this. I'll switch this on somehow. You can do the same and make it pull down, and it will go to ground. So that's basically what we did. So internally we could do this. So that's why I asked you for 4K7 resistor.
Yes. So we could manually do it.
Yes. So what we did now is when there's nothing happening, no information is given, it will always be a high. There's no doubt about it. So let's say the same is done with the push of a button. If you have a button, and it can bounce, we'll get there, but it can bounce. So what we do, if I don't push it, it will just be high or it will just be low. It's just to give a state to the pin that it will always know is we control the state it is in, should I say. But that is amazing. Okay, that is fantastic. So that seems realistic. Does your house seem like a 21 degrees, 26 degrees?
Well, it was more realistic 24, but I think it's cooling down from
your hand.
My hand, yeah.
How far is your water from you?
Quite far. It won't reach.
Go get a glass of water and then shove it in there. See what happens. You shoved it in, didn't you?
Yeah, I did. Quite dramatically.
Yeah. But yes, so what's actually happening now as well, you see in the code you've got delay 1000. on the left hand
Oh,
side
yes,
in the
yes,
code
yes,
itself.
the red one.
So that's just like, so it's giving you information, and then it's like, cool, wait for 1,000 milliseconds. So I think it waits for a second. So every second you'll get the information. So if you remove that,
Okay.
it will just be continuous outputting.
Okay, like the one we had earlier where
Yeah.
I had to stop the auto scroll.
Cool. So yeah, so your water's quite warm though. Tap water, I guess.
Yeah, it came straight off the tap.
DS. I just wonder what temperature it's going to go to. Let's have a look.
There's a maximum or not? Well, it looks like minus 127 is the minimum.
No, I think it's either 8-bit or 12-bit.
Oh,
So it's probably just 1111111. Just thinking. I'm just thinking about how much detail to go to. Trying to take it slow. DS. Waterproof. I wonder if you can put boiling water. I'm glad it works though. Yes, I was feeling shit. We can go to 125 degrees, so it's minus 55 to 125 degrees Celsius.
okay.
That the thing can handle. It's a big range, so you can boil water in a kettle and shower in there.
All I needed to measure is about maybe 5 degrees maximum.
Yeah, but it's fine. That's fine. Okay.
5 degrees.
Yeah. So this thing will have resolution of 0.5, I think. Yeah, 0.5 degrees. It's intervals. So it can be accurate.
Fairly accurate.
Yeah, it's accurate enough.
It's got 0.6, 0.12.
Did you take it out of water now?
31. Yeah, I did.
Okay, sure, I was about to say something. So you can actually just delete that in the code. Just delete serial print Fahrenheit, serial print measure, blah blah. Get my index. Bottom. That one. Take away Fahrenheit. No one works in Fahrenheit. No, the whole 2 lines. From the beginning, serial print.
These ones.
Yes, delete. And now you can try again. Yeah, okay.
And I was going to get sideways.
Yes, so you can see that there's serial print. If you make it serial print line, it will print on every line. So if you say serial print LN at the end.
Next to the serial print.
Yeah, just say LN. There we go. So if it's orange, you know the computer understands it. So now you can try again. There we go. Nice. So you get serial print. So serial print will just print one after the other, and serial print line will print every line. But that seems
and
pretty.
For actually the program to read it, like if you now set RGB, you must read this. Will it prefer a line or?
What do you mean?
So when we tell the program you must read this temperature.
So what are you going to do? So what are you going to do now is you see that sensor dot request temperature, and then you say sensor get temp by index 0 in the code. Yeah, so we say serial print line sensor dot get temp by index 0. So that sensor dot is actually going to give us a value. So if we go So if you go on above setup, say, I think you'll need, yeah, just start writing. Click. Does float? No, we're going to code now. Float. Space. Temp, T-E-M-P, is equal to 0. And then semicolon. So, no, semicolon, what's that? No, not semicolon. What's the thing behind all the code? What do you call it?
This one.
Yes, so that's just to say I'm done coding for that line. So what we did now is, you do know integer floats? Not really, eh? So
No.
integer is just a normal number, 1, 2, 3, 4, 5, 6, 7.
Yeah.
A float is just a number format where we can have decimals. So
Okay.
so you can have 26.55. So that we have a float. So it's just the way the numbers represent it. So integer cannot have decimals. So if you say int, it won't be able to say 25.4. It will just say 25.
Okay,
So we gave it the name temp. It's equal to 0 because we just want to give it a base. And now we're going to go at the bottom there where you say just above serial print line.
Yep.
No, sorry, below the one below it. Yeah, just above.
Space, yeah.
Yeah, enter. Yeah. Now you say temp is equal to copy that sensor.get blah 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 blah. At the bottom there, sensor.get temp. Yeah, copy that.
The brackets.
No, just the inside. Paste it. And then you have to end it again with a semicolon or whatever you want to call it. There we go. Now you can delete the inside of the bottom print line sensor.get. And make it temp. So but basically what we did now is we just said, okay, we've got a variable called temp, and the value of that must be stored in temp. It's just easier for us to use it later on. I'll show you now why. Upload and see if it works.
Okay.
I hope so. Yes, see, so now it does the same, but now we've got a variable called temp that is more easier to use in the rest of your code. So now what you asked for was, okay, so if it's 24 and I want the LEDs to do something, how are we going to do that? So we're going to use that temp. So we're going to use stuff called the if statement. So we're going to say if the temperature is between 24 and 25 degrees, do this.
Okay.
So that's all. So we're going to say if temp bigger than 24.5, make it green. It's going to make it green.
Oh.
Yeah.
Okay.
So it's
Okay, so that's where that comes through. Okay,
yes.
now.
So we just made a temp because if you can't go sensor.get, you can, but it's just not nice to program like that. So you can actually take that temp equals and put it above sensor temp request temperature. Okay, yeah, that's fine. Get temp C. Okay, yeah, so that's cool. Do you want to put the LEDs on, or do you want to do it tomorrow?
Do we have enough time for half an hour or so?
Yeah, let's just start. If you're happy till 2 o'clock?
Yeah.
Yeah, okay, cool. So do you have the LEDs?
Yeah, I do.
Great. Make them work. Okay, so let's just, LEDs got, there's red, black, and a middle one, right? 3 pins, 3 wires.
So I've got one with a RGB connector, which is red, green, and white. And then I've got 2 separate cables, which is red and white.
Okay, I'm just gonna have a look. WS. Oh, so you got the 4-wire. I don't know. So it's not 3 wires, it's 4 wires.
Got 5 wires actually.
Can you take a photo? Because
Yeah.
it's just supposed to be 3. What did I do wrong? Did
So
I
there's
get...
three wires connected to a 3-wire connector, and then 2 separate
Oh, okay, yeah,
wires.
that's fine. The 2 separates just to daisy chain it, so that's not an issue.
Yeah, it's the three wires.
Okay, that's perfect. That's fine. So this is going to be fun. This is going to be easier actually than the water thing. So you're going to take the connectors. Yeah, I kind of forgot it's got a connector on it, right? So can you put
Yeah.
a male pin in there, or does it not go in?
The male pin does go in.
Okay, cool. Put the red male pin in the red one, and then the female side in V in of the ESP32. The black one in the black one, and that will go to the second ground on the...
So there isn't a black one. There's a green, red, and white.
It'll be white. So it'll be white. It'll be white. It'll be white. So white will be ground then. How dare they do that?
So must it go into the ESP or the project board?
It takes straight to the ESP. It's the same. It's all the same. So
I'll do this while it's connected, or should I unpower it first?
no, unpower it first. Just unplug it. Rather be safe.
The power one.
The red one, yeah.
Must that go in? Must I unplug the temperature?
No. So on the ESP32 there should be a V in.
Okay, you wanted that one.
Yes, that one. That's 5 volts. Do you have a male to male one?
Yes, I do.
Yeah, sorry man. Rather take the red and plug it into the breadboard next to the 3-volt 3. So what you same thing you did with the temperature sensor?
Yeah.
So now you'll have 3 red ones next to each other.
And then the green one?
That's going to go in your your ESP32. I'm just thinking what connector we can use. Let's use 6. 6 16. Do you see a 16? And then
No,
no 16. Okay.
no 16.
21. I know 21 works. We use 21 in ours. 21 or 15. One of those two. You choose.
21 plugged in.
Okay, great. Then I sent you a link that we can use quick. Cool. So if you go down. So that's just explaining it, connecting it. There we go. On top.
The program. Sorry.
Yes, there we go. So if you go on top, go to Arduino again and search for fast LED in the libraries. There, top one. Nice. What did you do now? There we go, top one. Yeah, install that one. Let's see what happens. And now we're going to do the same. We're going to add the library to this. Yes, and now you can see define LED pin on the left hand side. Take the So take the just take all of that. Copy.
Does this need to go above the top, or is this?
Yes. No, you don't have to take. Yeah, you can take it. Take all that. You can read it as well. Then. Yeah, take a copy. No. Sorry. Not that far. Just the top. Just the setup. On top, yeah, with one wire, so we say one wire, Dallas temperature, yeah, you can do it there. It's just nice keeping everything. So LED pin you set in 21. How many LEDs do you have?
Ooh.
Just count.
Oh wow. Okay.
There's a lot.
Yeah.
You can keep it 14. It will only switch on the first 14 then. So that's fine. That's just to test.
14, okay. Yeah, no.
And the LED we have is, I'll send it to you on. So you see the LED type?
60.
No. Oh, what do you mean 16? 660?
Yeah. According to the invoice.
Okay, rather just make it 14. I'm a bit scared that LEDs take
power.
current. Yeah, I'm just worried the power of your PC. Let's rather be safe. And make the brightness 30. I just want to see them working. Yeah. So that's just the brightness of the LED. I think I'm going to go to 255. And the LED type is a WS. I copied for you in Discord. So it's just the LED we're using. There we go. And I think that's correct. Green, red, black, blah, blah. Yeah, that's fine. That's just green, red, blue. That's just the order of the stuff. Okay, so let's see if we can turn something on. If you look at the code on the left-hand side, let's just go slowly through it. Let's go down. So we go current pattern. That's just rainbow currents. Go down. I think that I just want to switch it on. So if we can go to Arduino again, just go to Arduino, because this is going to make your whole patterns and all that stuff. Save this. Just make sure you save it. Save. Yeah, great. And file example. So go down, fast LED. Let's just blink. What's blink? Analog output color. I just want to switch this stuff on, man. Yes, I want to make it. Just go to blink or go to color palette. Let's see what that code. Top. There we go. Let's see. I want to see how complicated this code looks. Okay, looks the same. Yeah, I mean, and you say analog output. What happens? I literally, this is just it's gonna go through a demo that puts on all the lights, change the colors, but I don't want to go that far now. So just go file example again. Sorry, man. Maybe we're gonna have to. And you say analog output, the top one.
That's right. That's as far as it goes.
Yeah, but it might not be the same fast that even when you're not using a pixel where it is. This example is designed to control an analog RGB LED strip for single. Yeah, it's not made for LEDs, man. This is just for normal, simple LED. Okay, let's try again. File example, last one. Otherwise, we're going to copy the complicated stuff and just put it together.
First light.
Where's the first light? Yeah, go first light. I just want to switch it on. Why are they being so difficult? Just make it green or yeah. Okay, let's go. Number of LED 60 data. This looks good. Go down.
That's as far as it goes.
Yes, that's good. Okay, so what they've got is, so we've got the WS. Just go up. So they've got the number of LEDs we've got the data pin, which is 21, clock pin. Don't know what the. Okay, so then we already said that we're using a WS, so I don't think we need to do that again. Go down.
Yeah,
move a single white LED. Copy that code.
The whole thing.
For int, yeah. No, sorry, not the whole thing. Just the once in loop. Yeah, but just inside, because we already have a loop.
Just a split.
Yes. Okay, just put it in a loop. Anyway, okay, try to compile. What LED, number of LEDs. Yes, okay.
Error.
Yes, because it tells you. So you got to enter the input. Cancel that thing at the back for. Just go back to the example code. Did you cancel it?
No.
Okay. Because you didn't copy over the last part. So when you see for int, then at the end you got that squiggly bracket that's complaining about.
So those two.
No. So what you yeah, so you see what's highlighted, yes. So every single pair it's telling you that for the for loop, everything there will happen in between those two brackets. So if you go back to your code,
So I need to add that
no,
bracket.
yeah, so at the bottom, enter, no, it's going to be the opposite, eh? So enter, yeah, you're going to have to add another one of those. Enter, and then shift, and then, yes, and now it's got friends. So it's saying for int, so a for loop is just basically, it will go for the white LED 0, and it will go until the number of, it's less than the number of LEDs, and then it will increase. That's a for loop. So it should be fine now. Compile. But we can go further. I don't want to bombard you too much.
Done compiling.
Okay, let's upload. Let's see what. Well, how are you connected now? So yeah, you should be fine. You got your ground. Okay, let's go. Let's go.
So the ground's connected directly to the ESP, and the file is connected to the board.
Yes, perfect. Let's go. And then your middle one is connected to pin 21.
Yes.
Okay, let's upload. Let's see what happens. No, you're not going to see anything. You're supposed to see a light now in front of you.
I just wanted to make sure it was enabled.
Sorry?
Do not see any lights.
Okay, that's not good.
No, I don't see any lights.
Go up, 21, you got the colors, number of LEDs. You are using 21.
Only 21. There it is there. White is on the board, which is ground. 21. Yeah.
So you're not seeing a white light jumping from left to right.
No lights.
Okay, what are we doing wrong? So we've got RGB. Go back to the code where you took this from. The example, sorry. First light, right?
Yeah, that's the one I did.
Yes, let's just have a look at it. Click on it.
Oh.
Yeah, so what did we not add? So fast clock pin.
Didn't add that.
I think we had it. Let's just look.
Oh, we did.
Yeah.
Yes,
So then sensitivity check delay allows programming.
setup. Didn't add anything for setup.
Yeah. Okay, add the fast LED.add LED, but the one we have, the WS281B. If you see it on the right hand side.
Yeah.
No, not that one. So that's not the LED we have. We've got the WS2. Is it that one? B.
1B, yeah.
Okay, let's copy that over.
And the setup, right?
Yes.
And a separate.
No, yeah, on a separate line, but the same. No, not brackets, yeah. It has to be inside the brackets. Yes. Okay, then just delete the front forward slashes because that's making it a comment. Yeah, delete that. So WS2812 data pin, which is 21. We have it on top, right? That must be LED pin. That might be the problem. Make the data pin inside. You see, make that LED pin. You see what we're trying to do? Yes.
Yes. Make it connect, communicate with the right thing.
So color order, RGB, LEDs. We don't have a variable called LEDs, so okay, that's fine. Let's go down. Go on top. Go right on top. On the right hand side, the one we're in. Just go on top. I just want to see what they. LEDs means. Great. Try now. Upload the left hand side one. Let me know if you see any lights.
Yep.
Do you see lights?
I see lights.
How's it going? Is it going left to right to 14 LEDs?
Yeah.
Great, man.
There's a red light going from the start to the end.
A red one?
Yeah.
Not white?
Yeah, red one.
Oh, so the light's red, not white?
Yeah, it's red.
Okay, I think it's because if you go to... so you see...
So now there's...
if you see where your cursor is now?
number 15 is permanently on.
Yeah, I think it's because of your resistance, but it's fine. We can sort it out. If
This one doesn't seem to go on.
Which one? The first one?
Yeah.
Okay. Changed, but where your cursor is now, you see RGB? No, where your cursor, where your flashing thing is.
Yes.
It's RGB.
RGB.
Make it GRB. Okay, cool. Upload. Anything happening?
Same effect.
Same effect, okay. RGB, GBR, GRB. I wonder if you change the top, you know you got CRGB LEDs number. If you change that to GRB, does anything happen? Capital. No. Okay, so it doesn't like that. Okay, no. No, okay, but it's running, right? It is. It's just strange that it's red. So
it is
make
one of the lights run from the start to the end.
So go number of LEDs, make it 20. Let's just see if it affects it. I just want to make sure we actually have control of it. Upload it.
Yep, definitely gone further now.
Great, but still red.
Yes.
Yeah, it's got to do with the color sequence because it's supposed to color order. Do we put color order anywhere?
It's when you first light is a constant red.
Yeah, it's always it's because you're supposed to put a resistor in front to help it but it's fine. We can solve it.
Yeah.
It's working. I'm just seeing the color sequence, color order. Does it get used anywhere? It should not be red, man. It should be white. At the bottom, you see LEDs. White LED equals CRGB.
Side or left hand side?
Left hand side. Right at the bottom. Right at the bottom. But let's first do something. So let's first do something. So now we're getting temperature and this. So I want you to go above the 4. Move a single white LED. So above that, right at the bottom. Yeah, down, left. Yeah, above the move single white LED. Below the delay. Above that, we're going to write some code. Down. Yeah, let's F. Sorry.
Yeah,
no, that's fine. F, open bracket. No, a curved bracket. No. Shift 9.
Shift 9. Oh yeah, correct one.
Yeah, so temp, TEMP, is bigger than 27 degrees. Oh no, let's say it's below 20 degrees. Less than, a shift less than. That's more than.
I always forget which one it is.
Yeah. Close bracket at the end. The round one. Yeah. So enter. Squiggly. Not squiggly. So the same one we used after the 4. I don't know what you call it. So after the 4, we had issues with it earlier. I must learn the word for it. So you put shift and the one next to the P. Yeah, that one. So we have that in front. So we're going to say if temp is smaller than 20, do this. So we open it, but we have to close it as well. So we close it at the end of our LED. Go down. Yeah, so at the end of that. Enter.
Another one.
Enter. Yeah, another one of that. Close it. Yeah, you see they're friends now. So everything in between there will happen. Upload this. Let's see what happens. There should be no LEDs on. We should have elsed it, but it's fine. Any LEDs on?
Nope.
Okay, so go to the monitor. Yeah.
Shall I put it in water and see if it comes on?
Yes, that is the plan.
Temperature water there. Come on shortly.
Oh, here we go. One more. Is it on?
Yep.
Nice. Now if you take it out, it should go above and then it should go off. So that's cool. That's basically what we're going to do.
That's really cool.
See how easy it was actually, eh?
Yeah. LEDs are a lot easier than the temperature probe.
Yeah.
So it's not breaking and then...
Now it should go off.
Okay, the 21st light is still on red.
Yeah, because...
But it's not...
It might be because we interrupted it while it was going. So we don't switch it off again. So we interrupt it straight away. But that's the gist of it for now. I think we made good progress.
I'm impressed.
Good, man. Good. So we can.
It's quite cool. It's like the whole theory thing, and now you're seeing it
live
different,
in front of you. It's different, and you actually control it, but it's also just taking bits and pieces from all over and just trying to make something.
Yeah.
Cool. Try to change the white, so you see LED, white LED. No, not that. That's just the variable. That is so what it's saying is int white LED. So we're going to start from 0 and move our way up to the 21. Because number of LEDs. So it will carry on until the number of LEDs. But let's just change the white. You say RGB white. Down. It says down. Yes. Make that blue. Let's just see what happens. It might not be blue, but it might not be red. Upload, let's see what happens. Yeah, now you're going to have to put in water again. Put your serial monitor on and you can have a look at the temperature. You can actually remove the delay, then it'll be much quicker. The delay of 1,000.
What could you move it to?
Like
zero?
half. No, not 0. Then it's going to probably see it. But then your temperature will get measured quickly. Oh, it's coming. It's coming. Oh.
2020.
Yeah?
Mm-hmm.
What color is it?
No colors.
Okay, then blue is probably not a variable. Change it back to white then. I have to do some research. GRB. Can you change that CRGB? Can it just be GRB without the C? No, delete everything and just GRB? What happens? Okay, do the same to the top. Just GRB. If you upload it, what happens? You can always Control Z. Upload. Okay, and you put a C in front of it, it doesn't help. Capital C? Yeah, it's not, it would...
Because there's another one there. So I need to change that one to GRB then as well.
No, because it's already complaining that GRB is not a name type. But so just Control Z and take it back. Let's just try to get your LEDs back. There we go. Okay, upload now. Let's just see if we get white back. I'll just have to do some reading. You're compiling. Doesn't matter. So ask Kerry. Kerry does all the programming with the LEDs actually. So
Yep.
white back? Or the red back?
It's red. Red is back. Oh, at least the 21st one has not disappeared.
Yeah, I think it's because if you go above 20 again, and we just stop it straight away. We don't tell it, okay, first switch off the LEDs, and then
Now it's back.
okay, it's probably just the resistor in front causing some noise.
And now it's gone again.
Horrible.
It seems to alternate every now and then. It does it.
Yeah, it's noise. We have the same problem with the coasters. We have to put a resistor in front of something. You'll see a lot of the documentation says put a 100 ohm resistor in front just to suppress the signal. But irritated that I can't make it white. Yeah, I'll have to read exactly what the see RGB does and stuff, and the fast LEDs show,
Yeah.
because it makes it black. You don't have black LEDs, so I think it just means to switch off. We made it. You type blue, right?
Yes, so type blue.
So what up? Type red. Let's just try red, and then we see what happens.
Severe space or not? You know.
I don't know. It should be the same as the white one. Probably small letters, but try.
Oh.
I'm just assuming because the black and white was. But you should actually be able to put hex numbers in there. So the 0x45. I don't know if you've ever seen RGB compiled. Anyway.
I know about the hex numbers,
Yes.
but I've not actually done that.
Yeah, but that's just the color coding. So you should actually be able to put it in and get any color you want.
It is red.
Oh, so still red. Okay, something's up.
Still red.
Something's up. But it's fine. I'll do some research. I think we made some good progress.
What? Red, blue, green. Is the... I know with RGB lights that if you connect the power into a certain one, it will change the color.
Yeah, it's not.
It's
It's
not like
this is not the same. No,
it's
you
not,
no.
Oh, it's not.
So you give it a data signal, and it will read depending how fast you go. It will, you tell it which one to turn on, what color to turn on. So this, I know what you're talking about. So it's not like that.
Yeah, that was PC ones where you
Yeah.
plug it in incorrectly, you can screw it up.
Yeah. Okay, so that didn't help. So just go. It should not be red, man. We are doing something wrong, but I'll try to figure out what. You go get ready for your games, but you can change it back to white.
Right.
And then can you just take a video? I'd like to see how it actually looks. And then send it to me through
Yeah.
WhatsApp.
I can do that.
Yeah, I was just interested to see. It's quite cool. Great, man. Great. I'm irritated that's not white, though.
Cool. You should get the WhatsApp video now.
Cool, man. Thanks a lot. Great.
Pretty cool.
So if you go, let's just. Okay, cool, man. You can get ready for your game. I'll check also what's going on here. Try to understand the GRB, but then next
Yeah.
time we can get more deeper into it. Try to make it more colorful, different temperature ranges.
Yeah.
What other sensors do we have? It's only light and temperature now, right? And then we can focus. Yeah. Great. Sounds good. That sounds good. I think that's it. I think we did well. We did well.
I did well. The fact that the stereo is actually it's
Working.
reading the temperature of our water, and there's lights going according to the temperature we've set.
Yeah.
Not the right lights we want, but it's at least there.
Why is it red? It's not supposed to be red.
Can I send you that? Oh, do you not have the?
Have
It
the
won't
what?
work if I give you the program. I was going to say if I send you the program.
No, send it to me. I'm going to order these components and build them myself as well. I've got the LEDs. Should not be white, man. But I'll speak to Kerry. Kerry will know. Because
Use the program.
yeah, she did all the LED lights for the coasters and made it pretty and stuff. So I'm going to let her do some stuff and then we can take it further from there. Fantastic, man. Fantastic. And this low brightness. I think it's going to look pretty cool in your fish tank.
Yeah, it'd be quite nice.
Yeah. So later on,
Okay.
you can boil some water and then see if it actually. You can. It says 125. So
And see how far it goes.
yeah.
But if we get the concept right, then I can always fine tune it and play around, and we can
Yeah.
make it programmable so you can.
Yeah, when you have time, just try to change the white to hex and see. So the
Yeah.
fast LED is a very popular library. So there were a lot of tutorials about the fast LED.
Okay.
So we can have a look. We can have a look. What time's your tournament?
I need to go start getting practice now. My
Practice.
teammates are.
Great, man. Have fun, man.
Oh, thanks very much for it.
Pleasure.
And I'll catch you
Enjoy.
again.
Cool. Chat again.
Cheers.
Cheers, man. Bye.